Welcome back. In this video, I'm doing Leetcode problem 263, ugly number. Today, daily question was 264, ugly number iteration 2. So I thought why not try to solve ugly numbers of first iteration because I haven't done it already. Okay, this is easy. So Leetcode easy, let's check it out. An ugly number is a positive integer whose prime factors are limited to 2, 3, and 5. Given an integer n, return true if n is an ugly number. Okay, if you watched my previous video, so we saw what are ugly numbers, and so ugly numbers are all positive integers, like it said, that are whose factors are limited to 2, 3, and 5, and all composite numbers. So we have prime numbers and composite numbers, and all composite numbers are factorization of some prime numbers. So yeah, makes sense. So each number we have is either 2, 3, 5, or composite number which is built by factorizing 2, 3, 5. There is no other way to build ugly numbers. Okay, to check if some number is ugly, we just need to divide that number by 2, 3, and 5 till we can, and if we get the rest, so if when we divide it by 2, as many times as that number is divisible by 2, and the same thing for 3 and 5, we should get 1 if it's an ugly number. So let me call that up. How I'm gonna do it? So we need to do, okay, like this. So for prime, let's say prime in 2, 3, and 5. So what do we do? While, so n modulo 2 is equal to 0. We will divide n by 2. So we divide n by 2. Okay, let's not divide then. Let's use so current is equal to n. Let's divide current by 2, and we need to use current here, and not by 2. Don't know why I did this like this. So p is 235, while current is modulo p is 0, we divide it by p. That's okay. So as much as possible. And in the end, we just return if current is equal to 1. And if it's true, then it's an ugly number. But one thing to note in constraints, we can see that n is between minus 2 to the power of 31. So an ugly number is a positive integer, so we need to check this also. So if n is less than or equal 0, return false. Okay, I think this should be it. Try it out. So, okay, seems good. Submit. And it looks okay. For the time and space complexity, so this is constant, we're not using anything special, so space complexity is of 1. Oh, it's filled with time, so time complexity is complexity of one and time complexity, so we protein, okay, our current P. I think this should be of one also, but I'm not sure. Let me check it, because in the worst case we're gonna have so we can have at most 31. Let me see here. So 2 to the 31. That's like at most we can, the biggest number we can have. So yeah, I think it's of 1 here. Let me check it out if I can't do. It seems to me it's of 1. I'm gonna check it out. Wait a moment. Okay, sorry. It's my bad. I thought this number, so this number is only 31, but log 2 to the 31 of log base 2 is 31, so it's actually log n. But since we only have like, this is the biggest number we can get, it's pretty small. Okay, I hope it makes sense. Yeah, thank you for following this one, and see you in the next video.